brought to you by Orbital Assembly Corporation, with your hosts, Dr. Jeff Greenblatt and Eric Ward.
Well, welcome back, everybody, to the latest edition of Our Future in Space. My name is Jeff Greenblatt. I'm the Vice President for Science and Research at Orbital Assembly Corporation. I'm joined here in the studio with my co-host, Eric Ward, who is the Vice President for Engineering Design at OAC. Hey, Eric, how's it going?
Hey, it's going really well. Our next guest here is Gary Calnan. He's the co-founder and CEO of CisLunar Industries. He has a diverse background in entrepreneurship, capital markets, and corporate finance, and now strives to help lay the foundation for a sustainable human presence beyond Earth. Gary, thank you so much for joining us.
Yeah, thanks for having me.
Yeah, absolutely. So could you tell us a little about CisLunar Industries and what you're doing?
Yeah, so at CisLunar Industries, we are building foundries in space. To process metal that comes from space debris and be able to recycle space debris, as well as other feedstocks that will eventually come from the moon, from asteroids, and even from raw materials just brought up from Earth in bulk that could be processed into very large objects that couldn't fit into a rocket. We're aiming to make basically two key products with this. One is the building materials you would expect, like wire for 3D printing. Rods, tubes, sheet metal, just the stuff you would get from, say, like a mill down, in your town, if you wanted to build stuff out of metal. And then the other thing is metal-based propellant, which enables some really interesting potential use cases and architectures where we actually use the debris itself as the fuel for going out and getting the debris, and then fueling the logistics chain to move the products around from that. So has some interesting capabilities there. And I should also say, we're a NASA-funded company. We've gone through a couple rounds. We're on our second round of funding from NASA, Phase 2 SBIR, to help make this a reality. We're well on our way towards hopefully getting this thing up into a parabolic flight by the end of this year, and for some early testing, and then up onto the space station for some longer testing in the middle of 2024. It's looking like around May-ish of 24, hopefully. You never know. Sometime around then. Sometime in 24.
Fantastic. It looks like you're making some really great progress. So I'm certainly happy to hear about that.
Yeah.
So we've also been talking about possibly flying some of your equipment on Pioneer Station when it's ready. And would like to hear a little bit from you about why this is an exciting opportunity for your company.
Yeah, I mean, there's a couple of interesting aspects around it. If we're talking about being able to create some gravity in space that's nearby, one of the really interesting things is the potential to simulate lunar gravity, because we do want to take this device to the moon. And in fact, talking to NASA, they see a lot of, really clear crossover from what we've already done. The guys who are interested in in-space manufacturing told us, hey, in-space manufacturing is our thing, but really this could apply directly to the Artemis program. And obviously there's a lot of funding there. So, it's interesting to think about how we could, de-risk and some of the technology development faster by using simulated lunar gravity in a spin setup. There's also some interesting potential manufacturing possibilities that we've considered that I don't think certainly no one's ever done before, where you combine both microgravity processing with an increasing gradient of gravity. So I don't know if that's where you're going with it, but there's some interesting possibilities that come up. So
yeah, no, we were really excited to talk with you about this a few months ago. And I mean, maybe you can just elaborate a little more. So what would be like the key advantage of having access to both gravity environments within the same station for you?
Yeah, well, that is still an open question, but we think that we know that there are advantages to processing in microgravity, because you can make certain crystal structures. You can make bulk metallic glasses more easily when you don't have the gravity vector, in place. There are metals that don't want to combine under a gravity field, but when you have them in microgravity, you can put them together. So, I'm not a material scientist, and I know that there's probably a lot more cutting edge material science that we could tap into when we have that capability, we got that furnace up there. But I believe that there's a clear possibility of making those materials in microgravity and then passing them down through a process where you transform this ball of material and you use gravity to do the actual, processing into whatever the final material is that you want, like a wire or something like that. Things that require sort of tensile strength or different sorts of, we can basically, if there's gravity, we can take techniques that are used on the ground now and apply them to space very directly to create the right kinds of grain structures and other material properties that you want from metals. But we can maybe start with materials that you can only make in space, and we can do so without having to bring them back to Earth or and really, we want to make things for space anyway, so it'd be better to keep it up there in the first place in a lot of cases.
Right. You'd hate to have to go all the way down to the ground just to get gravity again and then ship them up a second time.
Yeah.
Right?
Yeah, I mean, that obviously doesn't make any sense. Without some sort of spin gravity, we would have to find other ways. The other thing that's probably really much simpler is refining metals and sort of separating out different elements and removing impurities. I mean, again, lots of time, tried and tested techniques on Earth for these processes. So if we're recycling space debris, there may be ways to separate out different materials based on densities and whatnot that would be possible with a gravity vector in place. So there might be some advantages to doing some refining under gravity and then moving it up to microgravity when we have separated out the materials, and then using gravity again, to do some of the processing pieces. But I just, there's a lot to explore there. So it's very conceptual at this point. But
yeah, well, we're happy to provide the platform so that entrepreneurs like you can figure out the best uses of it. And meanwhile, if you have human, technical people who are part of this process, then they can be on the station and not have to be in microgravity the whole time.
That's true, right? And I mean, I would say that the demonstrating something, the technical viability of something in a lunar gravity field, if we want to go to the moon with our technology, is also a huge, potential advantage. So if you're going to be able to spin it up to lunar gravity, man, I mean, obviously the cost to go to the moon is a lot more than it is to go to Leo, right?
Yeah.
And the time as well is, I'm sure that there's going to be more of a launch cadence bottleneck in the beginning for getting out to the moon than there is just getting up to Leo with iterative experiments. So for us to dial in, we think that we can take something that will work in microgravity and use it on the moon, but surely there's going to be some differences. And, it's also going to be very different from how it is on Earth. So it's not like we can just test it on the ground here and have it work on the moon, because 1/6 gravity makes a pretty big difference for things like processing metals, as I understand. So it would be a great way to accelerate the tech development timeline for the lunar mission that we want to take advantage of as well.
Definitely. Well, I want to wait for you to get to the end of that thought, because I want to bring Joe into the stream, because he's been patiently in the back, in the wings, or in the dressing room. I don't know what you call it. So Joe, welcome. I'm kind of surprised that more people that we've talked to generally aren't seeing how that would be a big advantage. Because, like I think you said, it costs about 10 times. Well, you didn't say this, but I've seen this written, that to go to the moon, it's roughly 10 times the cost of going to Leo, right? Just based on the additional rocket stages. And it's something like $1 million a kilogram versus 10,000-ish to Leo. So, why wouldn't you?
So that's definitely an interesting an area of research there that I think a lot more people should be interested in, because not only is it expensive to get to the moon, but it's really cheap to get things from the moon back to Earth. So in essence, it makes a lot of sense to build things for infrastructure, especially heavy things, from resources on the moon. And it could actually make a lot of sense to build satellites and things that we have in Leo and in Geo from resources on the moon, at least from mass, like aluminum and metals that would be up there. So that's actually how Gary and I ended up meeting initially. Was I wrote a paper about this, how there's a good case to do metal refineries on the moon. The moon has a great deal of alumina and other metal resources on the moon. So this is a great opportunity. And yeah, some of the math that I've looked at, I think it's about 20% of the energy to get something off the surface of the moon to LEO. So, building space stations, if you want to do power beaming, that's kind of initially how I got into this whole thing is, hey, if we want to build power beaming, that's going to be a whole lot of metal. Aluminum is great for being reflective. With solar and stuff, you don't need things to be extremely precise as you would with antennas and things like that, where you need composites and things are better for some situations there. So anyway, certainly, enabling the space economy, we need a lot of metal, we think.
Right.
And we need to be able to get these metal resources from an area that takes less energy and less resources to move them, because transportation is really the biggest problem.
Right. Okay, so what I'm hearing is this is actually becoming an even more complex ecosystem, but again, with the benefit of doing things in low Earth orbit. So you go to low Earth orbit, and under lunar gravity, you test things, which you then send to the moon to do the refining. Then once you've done that, you send it back to LEO. And again, with spin gravity as one of the tools in your toolkit, you can do refining and other manufacturing processes for space-to-space application.
Yeah, I would just, speaking, we're talking to a lot of investors these days, and one of the things they definitely care about is, de-risking both on a commercial basis, a technical basis, financial basis. It's all about how can you minimize the risk and maximize the reward, right, when you're doing these investments. And, just accelerating the time for development and de-risking the technical risk for this stuff for a lunar mission, I think is huge, because that we can retire a bunch of risks nearby at a lower cost before we make the more expensive trip to the moon that might not be as frequent. So I think it's pretty key opportunity there.
Yeah, absolutely. I mean, I'm also thinking about the difficulty of building up a human presence on the lunar surface. That's still many years away. We have no guarantee there's going to be a lunar base, at least not one operated by NASA, maybe. But, whereas we're almost certain that there's going to be a population of skilled humans in low Earth orbit where you can do a lot of, technical development. Mm-hmm. So, all right. Well, we have a couple other questions maybe to just fire at you, but this is great. I mean, I think this really kind of gets to the heart of what we're looking at as, an advantage, we think, for us, and why people like you are excited to be working with us. From what you know about what we're planning to build, and you're welcome to ask for clarification, are there other reasons why you're excited to be working with OAC? You see as an advantage?
I mean, we see you as a potential customer as well. So that makes us obviously interested from both directions. We want to use your facilities, and we want to be able to supply materials for, if you're building, as you build out larger and larger ring structures, we might be able to supply like spokes and sort of the simple, structural members that might be able to be, done on Earth or in space. If we can save you a few launches, even though you can fit a lot of things in a Starship, we assume that's going to be a thing, right? If we can save you a couple of those, or if maybe speed things up because you don't need to wait for the next opportunity, then perhaps you're better off with the materials that can be made in space. So we can, and the way we would do that, I imagine, with any of these large construction projects, is we have the processing facility on site. It's like you bring the processing capability to where the construction job is happening, and you do your processing there and make the materials, and it's like made in-house at that moment. So
kind of bring the steel plant to the construction site, as it were.
Exactly. Yep. It's a modular space foundry. It's meant to be something that you can add the amount of capacity that you need, and the end effectors that you want to make the products that you need. So that we can integrate that. And the other thing that I guess feeds into that is, my hope is that there are other commercial companies doing manufacturing on your platform that we can feed materials that we're manufacturing directly into. So in that sense, you have kind of an industrial park whereby you have a cluster of companies. We have companies that bring us the materials that we need to process. We process them, and then we feed them directly down the line to other companies that can print the final product. If they're doing 3D printing or assemble, whatever their satellite or, we've got interest from people who want to do, make the dumb boxes that the sensitive equipment will go inside of, make that on orbit, and then save mass by only launching the stuff you can only make on Earth.
Right.
And that could be sheet metal and welding and that sort of thing. I would see you guys being able to host a variety of other businesses that are complementary, right?
So I think that specifically the ability to have gradients of gravity is very interesting to us. A lot of our IP involves manipulating metals with the luxury of microgravity and various gradients in space that are not 9.8 meters per second. It actually says that in one of our claims. It's things that are not 9.8 meters per second. So that hypergravity
covers a wide range.
It could be hypergravity. But we know that material properties can be impacted and affected significantly by how much gravity is there when we're processing. And also just, again, we're capitalizing on the fact that things want to float and turn to a ball, which has its pros and its cons, but really there's a lot of pros, especially when we start talking about higher temperature materials and things like this, where we might not want to touch them at certain parts, but at other parts, we may actually want to have some gravity or some gradient of that. So yeah, I think we've had a lot of ideas that capitalize on the fact that using rotating and the fact that you could have a gradient that goes from 0 to 9.8 or to some hypergravity. To be able to do that throughout, and there's no other place you can really do that on Earth. So this is very interesting.
Cool. Yeah. No, I mean, we can, the first station won't have that capability. I think we're planning to go to maximum of about 0.5 or 0.6 G, but from there, kind of the sky's the limit as far as gravity levels. It really just depends on what customers need and what they're willing to pay for, because it is a little more, challenging. I mean, it's just, you got to build a beefier system to sustain the higher loads, right, of hypergravity. And of course, we can build facilities of larger size. So if we need to house a more significant manufacturing capability with a few different key players, like you're talking about, a bit of an industrial park, they could all be located within one physical structure, or adjacent ones that are easy to ferry back and forth. Right.
I guess Joe sort of touched on a similar thing we had touched on before he joined. It's nice to get his alternative way of explaining it, because
I've got dogs barking. There's like something going on in the neighborhood. Helicopters flying over.
No, the dogs are fine. We've had sounds all day. Go ahead.
But no, I think that manipulating the environments in space that we don't have here on Earth is really unique. And the other thing that we talk about a lot is that, I mean, a lot of this manufacturing, metal processing, all these technologies have been around for hundreds of years. So, the ability to take those and apply those to space gives us a shorter runway for a lot of things. We're not trying to reinvent the wheel. We're not trying to reinvent the way metal is processed. We're really just trying to take advantage of the opportunities that we have with these new environments and see how we can apply the technologies that already exist to those new environments.
Right, sure. And miniaturization is, of course, an important part, but anything that you don't have to completely redesign based on Earth technologies is an advantage.
Yep, exactly. So, and also, we don't know what we might discover. We may discover.
Right. Yeah, I was mentioning earlier that there's materials where, elements that don't want to combine, but you can do it in microgravity. And that I know that there's some interesting properties that emerge from that. But like
glasses, things like this are pretty popular.
Yes.
So, and then of course, I'm really interested in the ideas of making, sheets and things like this. That if you make them in space, you might be able to make a sheet that's miles and miles by miles and miles. It could be unlimited in size. And so, how we do that, I think, is interesting. And so some of the stuff that I see, that you guys are working on could be interesting as far as making those capabilities, because we've thought of like, what does the architecture look like? Does the station need to move in order to put this big sheet out there. How does that look? So,
are you wanting to make 1 by 1 kilometer sheets for O'Neill cylinders? Like, why would you want to make something that big? Or
well,
that's a good reason.
Good reason. A part of it's looking for those applications. Seeing what people are coming up with. Initially when I thought of this, it was for solar sails and for power beaming as reflectors. So I think either with
there's also you may be familiar with this a notion to do a sunshade at the solar L1 with the Earth, and they will
global warming reduction, right?
What? Yeah, exactly. They will need extremely large, very thin sheets of metal to do that.
Yes.
And it'll require millions of tons of millions of kilograms anyway of mass to extract anything that would have any meaningful impact. So, obviously that's ways out there. That's like a mega project, these are the kind of things that would be enabled by being able to make materials in space that are very large.
Yeah, and it's kind of like it's hard to guess when that might occur, but we've definitely spitballed these ideas of having elevators, moon elevators, or some kind of a continuous way to get metal off the surface of the moon up to where they're up to some kind of place where you could produce these sheets continuously. Right. There's all kinds of things that could become possible as this technology develops.
Yeah, and I'd also just add that fundamentally, the way we tried to approach this whole project of building foundries for space is to make them modular and flexible. And the reason for that is that, we don't know exactly how the market's going to unfold, which market's going to emerge first, if it's going to be in LEO, if it's going to be a GEO on the moon, it's going to be in a rotating space station or on a non-rotating space station. And, obviously, if you're building a station platform, you want to be flexible to be able to accommodate a variety of ideas that people haven't even thought of yet, right? And so we're sort of trying to align ourselves in that way so that our core process is consistent and basically the same regardless of the implementation, and we can design end effectors or end modules that can produce a variety of things and put them where they're needed. And so I think that kind of flexibility should be an asset for having it hosted on any platform where you might have different customers coming in and out that could use different products from it. So,
right. Yeah, that's definitely thinking ahead, and also how to get started in a fairly limited volume, if that's what is offered.
Yep. Yeah. I mean, we're looking at something that's like a half a meter in length is kind of the size that we're talking about here, and something in the order of 100, 200 kilograms in size. And even with that relatively small size, we can still produce, something like 13 tons of material a year. So, that's just one unit. And then you add them together to increase their throughput. And the great thing about that is we don't have to build a whole bunch of them to start making stuff. We only build one. And if demand is higher than that, then we build some more,
Yeah.
Sure. You just keep feeding it raw material. No, it's fantastic. Yeah. And look, I mean, we've been wanting to talk to you guys, follow up on some earlier calls anyway, to talk about how we can really get you up on this station as one of our first customers, because I think, again, I think you guys really see the potential, perhaps more than most other folks. Like when we're talking to more traditional Earth-based manufacturers, there's a lot of convincing, to go through before they understand the value of manufacturing on orbit. But I think there's a lot of potential for us to find a way to, kind of help support each other, becoming each other's customer, essentially, as it is, and therefore get to the point where we can point to, you can point investors and say, look, we already have these customers lined up. They're going to use the station. Here's how much they're willing to pay. So let's continue that conversation offline.
Yeah, absolutely. I mean, we're talking about, and this sounds kind of like a little bit ridiculous at first blush, but we're talking about $1 trillion plus economy here that will be in place in the next, decade or so, maybe even less, depending on how things go. I think it could be less. That's actually a pretty conservative growth rate, for things like this. We're talking about a whole new industrial revolution in space. And each of our pieces of this puzzle are going to be a key piece in that value chain. And to enable that value chain means that any one of our businesses should be rather substantial when we get to that point where this economy starts to come together. So
you need room to grow. Yeah. I mean, and I think they all have the potential to grow to be a very large component of this future economy.
Yep. Yeah, exactly.
Yeah, and I think that if we look at global situations right now, obviously there's competition in space, which is going to motivate these things to continue happening. Technology is there to do quite a bit. We've got Northrop capturing satellites. We've got the Chinese captured satellites. So, I mean, unless that stops tomorrow, because
right.
I don't see that happening.
People get tired of it.
It seems to me that China's invested a lot in space as being a future for industrial, and like anything else, you either compete or you lose, and so it's on us to keep the competition going, and certainly there's huge benefits to being able to manufacture things in orbit. What gets me going every day is thinking, hey, the best way to save the world is to not use as many resources. I mean, there's all kinds of different ways to look at it. It's like let's just consume less of these resources, and maybe consume resources from places that are already inhabitable and already places that don't sustain life.
And consuming less, but not necessarily constraining growth of opportunity and technology. Yeah, and that, I mean, taking it one step further, like building on what Joe was just saying, that has been sort of the motivating factor for me as well in getting into this whole thing. Is I see us expanding out into the solar system, into LEO and beyond, as the best way for humanity to have an abundant and expansive future. And the alternative is rather limited, in my mind, and not something I really want to leave behind for myself or my children or their children. So I think that, if we set this on a good path and we develop this industrial infrastructure in orbit, the future is bright for humanity, not just in space, but on Earth as well. So
I think the worst thing the worst concept for the world and for humanity is this concept that there's scarcity of resources. In reality, we can look at it with, we used to use whale oil, and afraid we're going to run out of whale oil. It was really expensive to light your house. And then someone was like, what about this junk that comes out of the ground? What do we do with this? Of course, no. So it's really not about scarcity of resources. It's about scarcity of ideas of how to utilize our resources.
You got it. Yep. Couldn't agree more. Well, well, thank you guys both for spending a few minutes with us today to talk about, how we're excited to work together and our visions for a bigger, brighter future, both on and off Earth. And so I just wish you the best of luck, and I know we'll be talking again very soon.
Our next guest here is Jeromy Grimmett. He is the founder and chief executive officer of Rouge Space Systems Corporation. Thank you for coming, Jeromy. Why don't you tell us a little bit about Rouge and what you guys do there?
Well, Eric, Jeff, thank you all so much for having me. Over here at Rouge, simply put, we build space robots. If you want to think about like R2-D2, if you're a Star Wars fan, or maybe Exocomps, if you're a Star Trek fan, that's what we do. We build these things to deliver services in space to support and assist either existing assets or even in the case of working with orbital assembly, help with construction and help with payload movements, things like that. So it's really an exciting moment to be working with you guys and building out some of this technology for future of space.
Great. Awesome. Yeah, we're really excited to be working with you. You have some pretty important capabilities for us. And so we're pleased to be partnering with you as we build out our in-space capabilities. So I guess the next question to ask you is, why are you excited about working with OAC? What are we doing that, gets you especially animated?
Well, I think what it. Whenever I look at the landscape, the spacescape in this case, right? When I look at the spacescape and I look at the orbital reef, I look at the newer generation of space stations and some of the assets and habitats that are being put into low Earth orbit. The thing that's always missing is, well, gravity, right? And having some sort of sustainable, long-term, viable location where people would be able to reside and stay for even more time than what's currently being done on the ISS. Now, what's attractive for us is that now we have a base of operations in sun synchronous orbit in SSO. So now we can station our spacecraft so that we can then go and assist other assets and other occupiers, other participants in the SSO inclination. We have a tremendous amount of delta V on our vehicles. However, having that base of operations simplifies our capabilities and it centralizes our ability to be able to move, potentially bring assets back for repair. I mean, there's so many possibilities whenever you have this type of asset in the location you guys are looking to put it in.
Why is SSO, sun synchronous orbit, especially attractive to you?
This is where most of the LEO assets in terms of satellites are concerned, are located. It's also the most heavily trafficked in terms of space debris, and there's a lot of work that has to be done out there. So it's really important for us to be in a location, in a sustainable location, long-term, so that we could then operate in a more effective manner and help clean up some of the debris that's in SSO. And having a station like this would allow us to not only capture it, but maybe bring it back to the station for reclamation, for sending it back down to Earth, right? For science, for study. I mean, there's just the possibilities are just too multiple to really talk about right now, because the imagination starts going and it starts getting a little crazy. It's a lot of fun.
We like that kind of crazy, I think.
Yeah,
that's
everybody.
exciting.
Anytime you take these types of endeavors, whenever you take these types of endeavors unto yourself, it's got to. I heard somebody say that what it takes is someone very unreasonable to try and go and do very unreasonable things in unreasonable time, in unreasonable times, in unreasonable conditions, and have unreasonable expectations. That is where innovation starts really happening. So I like to consider the fact that people call me incredibly unreasonable. I take that as a badge of honor. So I would put OAC right within there, because I mean, what we're trying to accomplish together is a massive unreasonable expectation, and I dig that.
Well, thanks for the compliment.
Yeah, very much.
Yeah, I think that's definitely part of that entrepreneurial mindset, is that we've got to just do it, get it done, without wondering
Nobody
about.
else is going to do it. I mean, if we're not going to do it, who else is going to do it?
Yeah.
Right. It's pretty obvious the way that kind of awards went. We're going to try and do some of the same traditional types of things.
Mm-hmm.
I don't necessarily think that's the best idea, but hey, that's me. I'm just a guy building space robots in New Hampshire. I don't know. I would have liked to have seen something a little bit different, but hey.
Well, I mean, that's okay. We're only talking about one solicitation from NASA, and there's lots of ways of getting things built in space these days. But I guess maybe I'll just ask. So, yeah, you do have a lot of potential partners that you could choose from in terms of folks building commercial stations. But, thank you for recognizing the value of being able to provide gravity on orbit. We obviously feel that that's a really important long-term enabling capability, and even in the short term, because it'll allow people to work more sustainably, and we can also do things both research and manufacturing wise on orbit that you can't do in a microgravity environment.
It kind of goes back to what we were just talking about, the willingness to go against the traditional way of doing things. Being the maverick, being the renegade, being out there a little bit and asking the question, why not? We're not asking the question of have we always done it. The questions really started coming in, well, why can't we just do it this way? Why do we have to do it this way? Who said we're obligated to follow this rule? I mean, you're talking to a company named Rouge. So, I mean, it's we're rebellious in nature and name. So, being partnered up with you guys, we were able to kind of explore that further together, and I think that really supported and deepened the relationship, because we were able to ask these questions together and kind of go against the grain together. And I think that's important if you're going to innovate, if you're going to make progress. You got to be able to have somebody that's going to join you, be, shoulder to shoulder with you, and go through that wall. It always helps. Two guys going through a wall is a little easier than just one guy. So I think one of the things that we've really enjoyed about working with Orbital Assembly is that you guys were not afraid to go against the traditional way of doing things, where we're manufacturing all of these, really vertical siloed systems, and taking the approach similar to the way Rouge is doing it, where we're taking off-the-shelf technology, we're integrating it together using our special sauce, right? We're using our special sauce to put these things together so that these robots can perform mission. And that's what you guys are doing there. So it really made a lot of sense to us on how you guys were going about this approach. It's not the normal approach. There's just so much vertical integration. Going with a modular approach, setting up a framework, and then bringing the components together, that's a far more efficient, far more cost-effective method as compared to the way that these stations are normally built. Then on top of it, you're going to spin it, you're going to put gravity, simulate gravity. I mean, and then you just keep adding the benefits, and it's no wonder we get along, because we see it. It's really easy to see.
Thank you. That's great to hear. Yeah, well, we're really excited, to work with people who sort of see the bigger picture and where we're going, and I think we are going to be able to build things faster, cheaper, and better, like you said. Maybe one last question, unless Eric has one for you, is how do you see what we're doing together, you and OAC and our other partners, fitting into the larger space ecosystem that we all want?
If you think about the turn of the 20th century, in the 19th and 20th century, what you had was you really had this, well, during the 19th century, you had this drive toward the West, right? Well, it's the same basic principle here. The West was pretty unruly, so was space. The West was always trying to kill you, so was space. There was no infrastructure in the West. There's no infrastructure in space. So it takes guys, it takes people like us, like OAC, like Rouge, and I got to invoke them. The SpaceXs, the Blue Origins. It takes this massive community to say, okay, let's figure out how to get up mass. Let's figure out how to make that more affordable. Let's get some railroad tracks put in place. Okay, let's figure out how to talk to everybody out there. Thank you, OneWeb. Thank you, Starlink. Thank you, Telesat. Okay, great. Now we're talking. So we got our telegraph lines in place. And what started happening? You start getting these little towns, right? You had these little towns before, but you started getting all these little towns connected. Same basic principle with this. We need this little town. Mm-hmm. I'll provide the little welcome sign and everything to slap on Pioneer. I'm happy to do it. And if we can do it in the old text, like an old Western town, I think
welcome to ye old space station.
Yes. I mean, if you think about it, I mean, it is called Pioneer, and that's what they were called, pioneers out in the West. It only suits that you have the appropriate lettering across it, So
we'll keep that in mind.
So my point in all this is that we have to build infrastructure, and you need the railroads, you need the communications, you need the settlements. You need the places we can build factories. You need the places where we can do research and development. You got to have places for people to stay. You got to have places for people to work. You got to have places for people to live. It's just the next logical step, in my opinion. And hopefully Rouge can support that effort by making things a little safer and not forcing people to go outside into space. Maybe we can do that with robotics and, maybe save a life or two. That would be cool. That'd be nice. So that's kind of how I see it.
Excellent. Yeah, I think we see things similarly.
Mm-hmm. Yeah, it's definitely the next step here, and we're pushing out into space in the future. So I think that's one thing we really like working with you, is that we all kind of share this vision and, are willing to kind of put the work down to get there and figure out how to make it happen. So
right, get it done. We love that.
Yeah, get it done. I mean, it takes a community. I mean, it takes a team to do it. Yeah. And I wouldn't be able to do it without you guys. You guys really couldn't maybe you could do it without me. But but it's so much more fun whenever you're doing it in part of a team.
Yeah,
true.
I hate to invoke the Lego movie, but everything is awesome, and it's even better when you're part of a team.
Part of a team, yeah. Absolutely. Well, thank you for joining us. I think we hit our time cap here, but we really appreciate you coming on to talk, and looking forward to continuing to work with you, of course.
Listen, my pleasure. Thank y'all so much for having me, and if there's anything y'all need, just let me know.
Thank you.
Absolutely. Yeah.
All right.
Talk soon.
All right. We'll talk to you soon.
Well, thank you for listening to these short interviews. I hope you found them interesting, and we'll get back to the regular format soon. If you have any suggestions for future topics or people you'd like to interview, as usual, please feel free to reach out. You can email us at ourfutureinspace@orbitalassembly.com, or find us on Twitter @ourfuturespace or Facebook @ourfutureinspace.
And if you like what we're doing at OAC and would like to find other ways to contribute, feel free to reach out to us at info@orbitalassembly.com. Thanks for listening.
We'll see you guys soon.
Okay, take care. Bye-bye.
This program represents the personal opinions of the hosts and their guests. The content, opinions, and views do not necessarily represent the views and opinions of Orbital Assembly Corporation, nor the organizations with which any of the program participants may be affiliated. The mere appearance or promotion of this program does not constitute an endorsement by Orbital Assembly Corporation or its affiliates. Our Future in Space. Copyright 2022, Orbital Assembly Corporation. Hosts, Dr. Jeff Greenblatt and Eric Ward. Audio production by Tim Alatorre. musical theme, The Last Day by Dark Blue Studios.